All right. Let's do it. 71. Acceleration of gravity on planet Earth. Time flies beyond flying. Acceleration due to gravity on planet Earth near the surface A of t equals negative 9.8. Measure in meters per second per second. If a boy climbs into a 10-foot tall building, throws the ball upwards at the speed of 50 meters per second, find each of the following. Acceleration at 2 seconds. So I'm going to go ahead. Acceleration at 2 seconds is still negative 9.8 because there's no place to put t. Okay. Meters per second according to the thing. Or meters per second squared.
I read that.
Velocity. How do I find the velocity? I'm going to integrate negative 9.8 dt. Raise its power by 1. Divide by the power I get. Plus c. Agreed? And what's its initial speed? When I plug in 0, when I plug in 0, I should get 15. So here's, I'm going to officially do it. So 15 equals negative 9.8 times 0 plus c. C equals 15. Agreed? Now again, once again, if you're really confused, the Ozon's rule is going to work just about every single time because it's your initial condition, right? It's only when weird fuzz. Occasionally, this is one of those. Okay? So this is going to give me velocity with respect to time is equal to negative 9.8 t plus 15, right? So then I'm going to plug in 2, and I would get negative 9.8 times 2 plus 15, negative 4.6. Okay, that didn't sound convincing, but I'm going to say yes. Okay, sounds good. And because we lost a rate, we lose a per second, so this becomes meters per second.
Oh, yeah. I wasn't sure what you were.
Okay? All right, let me lift this up. Need the formula. There's the formula. Got it. Okay. All right. So now I want to find displacement, which I'm going to call y. Y of t is equal to the integral of negative 9.8 t plus 15 dt. So raise its power by 1. Divide by the power I get. Raise its power by 1. Divide by the power I get. Plus c. What's my initial position? I'm 10 meters up. So when I plug in 0, these two would cancel out, right? So it's going to give me 10 over here. So go y of t equals negative 4.9 t squared plus 15t plus 10. Now that is different from physics, right? Because in physics we normally put the 10 over here as a negative, right? We'd solve for when it gets to negative 10. Now we're writing an equation that works no matter where you are. How high are you? At time equals 0, this gives you 10, initial position. Whereas the physics way doesn't do that. You have to think your way through it. Good? All right. Moving forward, I'm going to plug in a time that I care about at 2 seconds. So y equals 2 is equal to negative 4.9 times 2 squared plus 15 times 2 plus 10. Brain melting. That's 20 minus 0.4. So 19.6 from 9.6. Almost had it. 21.4. No, 20.4. 21.4? Sorry, 20.4. Okay. 20.4. And that's how you get it. And that would be in meters because we lost another per second because we're removing them by doing integrals, right? We're removing the rate. So this becomes just plain old meters because we had meters per second, now we're at meters. Got it? Have trails? All right. We are done with this chapter, so the next thing I traditionally do with this chapter is I give you a quiz. Take-home quiz. That's what you're taking home today. We have one review assignment, and we're done. This is it. We've got it. We've got it in the bag.
Is this like one of the few chapters? Because usually we have more than 10 worksheets.
Yeah. I mean, if you remember correctly, when we did the differentiation of the original equation chapter, it was like this one. We did the formal definition of derivative, and all of a sudden magic happened, and we had the power rule. We were done with that in 8 worksheets plus 2 review worksheets. It's pretty much the same sort of thing. Because we got so much practice with the power rule, this is even more embarrassing. It's like, okay, but yeah, we do have to remember to do it backwards. That's a little bit. That's new. It's a little bit of a trick. We have to remember plus C, right? Remember plus C. Other than that, we're good to go.